thing is kind of a straight, at first I read this and I was like, I don't even know what they're asking here. It's basically just saying, is this equation true? Like, you're just trying to show that it works. It's basically like you're trying to get the two sides to match. So the identity, I actually probably should look and see what the book exactly says, because that's not very mathematical, what I just said right now. But basically, we're trying to show that A and B, like there, that those equations are true. So you're just kind of basically showing your work, doing the math. So they're giving you the answer, they're giving you what it equals. Now, if it doesn't equal, then you'd say it's not true. But then, I don't think there'll be any like that, but if you can't get them to match, then something weird is going on. Now this one's a little bit strange because there's two variables, and we'll talk about that in a second. So it basically says that the equation's true for all values of the variable where both sides are defined. So basically, it works for everything except the excluded values. So the equation works So a short way to say that is the equation works for all values in the domain. And it says prove that it works. It's not like we're doing this big, two-column proof like in geometry. We're just basically showing our steps. You can't just say check it works. Kind of like when we were showing something's the inverse equation, I needed you guys to show me, like actually do some math to show that. So we're basically subtracting on this one here, we're adding here and just showing that they simplify to be the same thing. So I'm going to basically work on this side and try to make it match the other side. Because I think breaking this up as two subtraction problems is a little bit more difficult. I think making it look the other way makes more sense to me. So I need a common denominator. Oh, sorry.
Wait, did you start the video again?
I did, yeah. Thank you for checking.
Wow.
That's nice. Uno.
Well, Uno, yeah.
Every time I hit record, I should say Uno, so that you guys know. All right, so I'm multiplying this one by n minus 2, and multiplying this one by n. Now when I'm doing this, I have to do a little bit, I'm a little worried that doesn't make sense. I guess maybe we might have to do something on both sides. Right, we multiply by n, yeah, okay. Does this work?
Yep.
It does?
He doesn't know.
Shouldn't it be minus 2n?
No.
No. Yeah, why not?
No.
Wait,
Because that's not
no.
what's on the
No?
board. Yeah, that's not what it says. Yeah.
But if you're multiplying.
Because if I do the top, will this over here cancel or something?
Wait, if you're doing n minus 2 times n, wouldn't it be n squared minus
No.
2? Oh, never mind, you took an n out.
Yeah. Yeah. Stone. What do you think?
Stop being so mean.
Holy, I'm getting blamed.
Yeah, you're
Well, I mean, you did almost hit that car.
Yeah.
Maybe this what?
It was their fault. It was their fault.
N squared minus.
No.
Dude, it's
Yeah,
not
because
so
these
slow.
cancel, right?
Yeah.
So it's like,
Okay. Apparently, this is what we're proving that's not true, maybe? I don't, like, because I'm looking, I thought this was a good example, but it says check whether the following is an identity. It must not be.
yeah. We were trying to figure
Sorry.
out. Yeah.
All right. So, bad example. But anyway,
It's proved. It says proved.
yeah, I guess we'll say that we can't prove it. Because if I try to factor this, yeah,
Yeah.
so this one's no,
No.
jerks.
I don't even know.
All right.
Yeah, what is happening?
The book had like an extra example on the side, and I just assumed that it was like one that would work. Can I have a whole bunch of like crackers in there?
You know what? Wow.
You know what a zoom is?
Here.
slow. Just slow.
Okay, so that one doesn't work. All right. So our next one here, I think this one works. But again,
It was you.
we're gonna work on this left side over here and see if we can get it to match. But the good news is this one's closer than you realize. It already has the same denominator because if you actually factor this one, although it's weird because it has a couple of variables, it ends up being the same. So we can just add or subtract the top here. So we're going to do 4 plus a negative 4. So that's going to cancel. And then to be a little bit nicer here, I'm going to have x minus a on top. So this is what was supposed to happen, is that these two would cancel, and this would just equal 1 over x. So it shouldn't take a ton of work most of the time. I guess there are times when they're not going to equal, so that's mean of them to do that. But so this one, we showed it by showing some work with it. The only thing is we do want to talk about the excluded values, and this one's kind of a strange one for excluded values because we have to make sure it works for all values in the domain. So x cannot be what? 0. What's the other one x can be? It's kind of strange. It can't equal a. If x equals a, even though we don't know what a is, if I have a minus a in the denominator, that won't work. So we actually will say x also cannot equal a there. It's kind of a strange one. You guys are ready? Flip to the back side. So we have these complex fractions.
Dude, I wonder what they think every day when they hear you
So
say.
we were laughing, like when John came, because John has me for a trig too. He came yesterday and he's like, can I stay at your room at the Dells? Because he heard us talking about the Dells
He's
yesterday.
like, I want your extra water park pass. I was like,
And now he's gonna hear us talking about this right now.
Yeah.
I know.
Well,
He's
it's
probably
like-
like doesn't skip through. He's probably just like everything we say. Hi, John. And it says hi to me and Trey.
Actually, I think he's gone today. But,
What?
yeah.
Well, he'll probably
Yeah,
still
he's-
watch it. Right?
Yeah, I would think he'd watch it.
Yeah, well, I hate John, so.
Okay. It just got serious. Okay. All right. So, just a reminder, complex fraction. Just
No!
Okay.
Get over yourself.
About like
Pull it together.
5 minutes.
I thought you guys were supposed to be taking a break when I was changing the video.
It was like 30 seconds.
Yeah,
I used to give Garrett like
just
CPR.
more.
He's gonna die.
5 minutes.
Overwork. No, it's not CPR.
Wait, so 3 over 4.
Okay,
Should
so
it be equals?
CCR.
Not divided?
this is just saying
Oh,
dividing.
that's saying
Yeah,
it's a divided
yeah.
line.
So this is the same thing as dividing here. Okay, so guys, remember with division of fractions, we flip and multiply. So just kind of reminding you guys, those complex fractions, this one's a pretty straightforward one. I don't even think anything cancels, right? So we just end up with 3x over 8. Then it gets evil here.
Okay, X.
I don't even.
Is there any like?
Oh, is there any restrictions?
I don't
Good
think so.
question.
X.
X cannot even zero.
Okay, so this is kind of a weird one because we do some flipping here, so you're kind of like, can x equal 0? No, we don't want x to equal 0 because the original problem has x in the denominator. So it's probably just safer to say let's have x not equal 0 in this case. It's probably better to have more restrictions rather than less, kind of like being safer than sorry. Okay, so letter B gets a little bit trickier because we have kind of some crazy fractions, so we're going to kind of work on the top first, bottom, separate, and worry about flipping them and multiplying and all that kind of stuff. So we want to probably simplify each of these first. We don't want to just flip this because we can't flip that 1 minus 1 over x squared. It's a little bit of a mess. So we have to simplify first. So what I'm going to do instead is kind of change these both to fractions. I think that makes it look a little more workable here. Now again, don't flip these yet. So I want a common denominator. So I'm going to work on the top and then work on the bottom of all this. So my common denominator here is going to be What's my common denominator? X squared. So this can become 2x squared over x squared. You okay with that? I had a bunch of guys asking me yesterday, can I cancel those x squareds? No, you don't. You just put them there. Don't cancel them. Leave them. And then same thing on the bottom is going to happen over here. These both need an x squared. All right, I'm still going to simplify this a little bit. So up here, I get 2x squared plus 1 all over x squared. So that's the very top of my complex fraction. Now we're finally ready to flip and multiply. Because now we have a fraction, a single fraction and a single fraction. Before we had multiple things going on there. Now we have to kind of simplify. So now we're going to flip and multiply. So the first fraction is going to stay as it is, or the top fraction. And then I'm going to multiply by this one flipped over. Any canceling? X squareds. Anything else? Can this be factored? No. The bottom can be factored, but since the top can't, it doesn't really help to factor it. I mean, if you want to show off your amazing factoring skills, go ahead, but it's not going to be helpful. So this is all we're going to be left with here. But what can x not be? What's that? 1. 0 as well. Anything else? Bless you. I think there's actually one other. It's actually a negative 1 as well. Negative 1 as well, because if we did factor this, this might be the only case for wanting to factor there, is that'd be x plus 1, x minus 1. So we have to include that as one of our excluded values. So anytime the denominator can be equal to 0, we want to throw that out. Good news is letter C is a little bit better. All right. Actually, a lot better, right?
Yeah.
Where did B come from? It's like usually it's like the last one is hard. So.
Can those y's cancel?
Good question. Can those y's cancel?
No.
No, because of that plus sign. So we will.
killed the kid.
Yeah, yeah, you did. Kitten killer.
I saw it. I was.
Either of these is fine. This is fine. That's fine. Don't cancel the y's. Yeah, you killed it.
Jeez. My bad.
Not only did you almost crash into a guy's car, but you also just
It wasn't my fault.
Did you almost have a car accident already?
Yes,
Why
yes.
this morning?
It wasn't my fault though.
He left his license at home too.
No, I didn't. My license is in my bag, not my wallet. It's in your wallet.
Okay.
Because
anyways.
I always leave my wallet at my house.
Anyways,
So
are you gonna tell her the story?
Yeah, so this happened this morning.
So basically, the person, I was at a stop sign, right? And the person's going, like, they were driving. And, no.
And so
And they had their blinker on, right? And then they went to turn, so then I like started creeping up to follow them.
Oh.
And then they like changed their mind and like went straight. So I almost like T-boned them.
Oh, that would have been scary. And did you end up getting out of your car or no? Like,
No,
I,
we didn't hit each other.
okay.
Like they just gave me a look and then drove off.
Yeah.
I was like, yeah.
It's okay. When I had my test,
I was so
accident,
scared.
and like I got flipped off for the first time with my mom in the passenger seat. Because there was a person in front of me that was going like 40 on the on-ramp, and I had to like speed up, and the guy like he was coming like on the highway or interstate or whatever, and he like would not move over for me, and I like couldn't get up to speed, so I was going slow.
Yeah.
So then he ended up like having to like brake and swerve kind of thing. I was
Isn't
like,
the
"What are you
on-ramp the
walking
only place you can actually speed, like it's like legal
Yeah.
speed, right? Because you're
Yeah.
trying to like merge on, because you're
And he like wouldn't move over from me when he had like the open thing right next to him.
Maybe
So,
within
like, flipped me
reason.
off.
Well,
I was like,
and
I don't know what you want me to
The
do.
person
here.
was like in the turn lane too.
Yeah.
So I was like,
Yeah.
Maybe they just like knew you, like so they were kind of.
no, we were close. We were like this close. So I was like second day. Like that's the only thing that was going through my mind. The second
Like
day.
everyone's gonna be like,
Yeah.
like kind of more on you.
Like,
second
my mom's
day.
taking my license.
Yeah, like this is it. Like it's over. Oh man.
Second day on the job.
Really?
Okay.
I literally was shaking my whole way to school after that. Like I was like,
I was driving.
Driving,
A near accident really like it spooks you. Like you're like yeah, you're like I'm
I
never
was
gonna drive
driving-
that again.
I was driving
Oh,
like
yeah.
1500 the whole way there.
I'm not gonna cap. I've almost been in like a couple accidents. But we know like fuck.
All right, guys.
Spits on my
And they were pretty much all my fault. But I did it once. So.
Yeah, like 3 in the morning.
Okay, guys. Let's finish this up. Sorry, guys. Just checking the time. All right. So this seems like kind of a weird thing to do, but if you guys notice that we have a curve here, and they want us to find the slope of the segment connecting these 2 points. So they have these 2 points here. They're saying just find the slope of this. We can't technically find the slope of a curve yet. It's kind of what calculus, the idea of calculus is kind of find that area beneath the curve. We'll get there. But we want to just find the slope. So this is kind of the starts of like dipping our toe a little bit into that calculus piece. And so when you guys look at this, our normal slope formula is y2 minus y1 over x2 minus x1. So we have our x and y, our x and y. Now rather than just using regular numbers, which is really annoying, I know, they're giving us just kind of these weird like x and h and f of x and h. They're kind of just being cruel here, and I get that. But I'll show you guys how this looks though. It doesn't look as bad as it seems. Especially the bottom, because x2 minus x1 is just these two. So that's going to be the bottom of our fraction. So I'm going to call this 1, 1, 2, 2. So x2 minus x1 is going to be x plus h minus x. Does that make sense? So I'm taking the x's and subtracting them. That goes on the bottom of our slope formula.
Do you have to put like a parenthesis right now?
You don't need to, bless you, because there's only the one term. There's only one sneeze.
Yeah, I don't know. It was the one from before because I felt forward, but
yeah,
I
the one.
couldn't sneeze. I could sneeze.
All right. So guys, now the y2 minus y1 is a little bit more difficult because it's saying f of x plus h. And that means I'm putting this into this function. So the x plus h is going in for x. So I'm going to write that here. So that's my y2. So I'm going to do 1 over x plus h squared. So if you guys see what I just did there, I took this and put it in for my x value. That'd be my y2. And I need to subtract y1. Minus y1 is just f of x. So that's just 1 over x squared. So take a minute to kind of like digest what's going on here. Seems like a lot, but it's not as bad maybe as it seems. So we're just taking those values and putting them. You're going to do a very similar question in your homework. I think yours is a little bit easier though. All right, kind of a few good things going on here. The bottom, the x's just cancel. So it's just going to be an h on the bottom. So I'll deal with that later, but just having an h on the bottom is a lot better than having all the other stuff going on here. All right, so now I need to combine these because these are these complex fractions, so I need to kind of put those together in order to like simplify that a little bit. So I want to get a common denominator here. Now if I did FOIL here, that would just be a big mess. The reason why is because I'd have an x squared, but I'd also have like an h squared and a one's denominator. So I'm going to give an x squared. This one needs the other one's denominator. Oh geez, I wanted to just move that. Oh well. So what I have here is I have x squared over x squared x plus h squared minus x plus h squared over. And remember, this is all over h. We'll deal with that later. All right, I'm going to tell you guys on the bottom, don't worry about foiling. In the denominator, typically foiling distributing is not usually very helpful. But on the top, typically you want to foil. So we want to figure out what that is because something's going to cancel up there. That's going to be a good thing. So I'm going to, off to the side here, I'm going to do x plus h squared. Don't kill a puppy though. Did you kill a puppy? Kind of an ugly foil there. That's just that little spot. So I kind of did that off to the side, my work off to the side. Again, that's why our worksheet's so bad, is because there's gonna be all these little side things you guys are doing. So I have x squared minus this whole crazy thing. And I am going to use parentheses now to remind myself I'm subtracting all that. Almost on a square. What do you guys notice? Anyone still there? What do you notice?
The x squares.
The x squareds will cancel, right? So what I'll be left with up here is I'll have a minus 2xh, a minus h squared, just lost it, I'm going to put this h over 1 just to remind you guys that that's a complex fraction. We're going to use that in a second here. So now we're ready to flip and multiply. And again, the ones that you guys have to do in your homework are a lot easier than this one. The equations are nicer. So I'm going to change this to flip it and multiply. We're going to be able to factor this a little bit. We can deal with that in a second. So I flipped and multiplied. There's a little bit more factoring I can do that's going to be a good thing. Do you guys see it? Take an h out at the top over here. They both have an h there. I'm going to leave those negatives in. We don't typically do that, but that negative's not going to help me at all. It's just going to confuse me more. So. Now those h's can cancel, right? So I'm left with, finally, this is the slope between those 2 points. And again, kind of dipping our toe into calculus just a bit here. It's a lot of manipulation to get something that you're like, really? Like what is that? Like, I mean, so, but yeah, this is where we're at right now. Right. So, like I said, the worksheet has a couple of these on the back side, but they're a lot easier than the one we just did. So, I promise.
Wait,
Now we can break.
why does
Why
is it change to only minus h? Is it because
Because I took an h out. Remember, I factored this h out here.
Oh yeah, okay. That makes sense.
Yeah. And again, if you have to do your homework on a separate sheet or something, feel free, or if you need to do scratch work on a separate sheet, like I said, like I grabbed this book worksheet and I like the problems, but the amount of space they give you leaves a lot to be desired, because unless you can write a lot smaller than I can, which you probably can. But.